All right, these are our 4.3 notes on rules of probability. We have three main rules that we'll be covering today. The special addition rule, the complementation rule, and the general addition rule. So starting from the top here, we have a definition for probability notation. And you can see if the event is named E, capital letter E, then the probability of E represents the probability that an event E occurs. So we read that, the probability of E. So next is our special addition rule, and you can see the special addition rule applies for two mutually exclusive events. And the special addition rule just says if event A and event B are mutually exclusive, meaning there's no overlap, then the probability of A or B is equal to the sum of the probability for each of those events. So in general, if you have events A, B, C, etc., and they're all mutually exclusive, then the probability of A or B or C or ... is going to be equal to the sum of each of those probabilities. For example, we're going to use the special addition rule to determine the probability that a randomly selected farm has between 100 and 499 acres inclusive. So we look at our table over here, and we find 100 to 179, all the way up to 499. So that would also include this middle range of 180 to 259. And so you cannot be both a farm with 100 acres and 180 acres, so that means that these events would be mutually exclusive. So you can see these are labeled event D, event E, and event F. So we have the probability of D or E or F is equal to, just like our rule above says, the probability of D plus the probability of E plus the probability of F. And so looking at this table again, we have the probabilities of each of these events listed, and so we'll just add those up. So we have 149 thousandths plus 77 thousandths plus 106 thousandths. And that will be equal to, we'll add those all together, .332, or 332 thousandths. So that would be using our special addition rule since our events are mutually exclusive. Next we have the complementation rule. And so we actually had an example of this in our 4.4 notes, talking about our professors and the ages, and our last example being the age, a professor over the age of 30, and so we were able to subtract the two professors that were under the age of 30. And so similarly, when we're talking about the probability for any event E, where E is all of the events included in the circle and not E would be within the square, 1, because 1 represents 100%, minus the probability of not E, so minus the probability that an event would happen outside of the circle, would give us the probability of that event. So for example, size of the farm. So we saw the first two columns of table 4.5 provide a relative frequency distribution for the size of U.S. farms. Find the probability that a randomly selected farm has less than 2,000 acres. So we could go here to our table and notice that 35 thousandths of the farms have over 2,000 or over acres. And so we could take, to find the probability that they are less than 2,000 acres, would be 1 minus the probability of not that event, or probability of I. So 1 minus 0.035 so 965 thousandths. And then looking at this next example, 50 acres or more, so you have 50 acres or more would be all of those represented here, and we just have events A and B that would be less than 50, so we could just take and subtract 1 minus 0.084 and then 0.265. And we get 0.651, or 651 thousandths. Lastly, we have the general addition rule, and here we have, in case we do have events that are not mutually exclusive, so there is some overlap in those events, then we have to subtract that overlap piece, as you can see in the equation, because otherwise we would be counting that space 2 times, both within event A and event B. And so to avoid that doubling up, we subtract that middle region, which we call A and B. So here's an example. We have, from the deck of playing cards, consider the experiment of selecting one card at random. Find the probability that the card selected is either a spade or a face card. Do this by sorting out all the spades and all the face cards. And you can see, without using the general addition rule, if we just look at the sample space, let E equal the event that the card selected is either a spade or a face card. And so we can just count these up. Spades, there are some spades that are also face cards, and the face cards that are not spades, and we get 22, there are 22 cards here, out of our total 52 cards in a deck, which is 423 thousandths. So the probability of selecting a card, a spade, that is also a face, or a spade or a face card, is 0.423. And we can also use the general addition rule. So that would be, so the probability of event E, we could also call probability of C or D, where we identify event C would be a spade, drawing a spade, and event D would be drawing a face card. So you can see the number of spades in the deck, and we know that that is 13. So we have 13 out of 52. And then we have our face cards that are not spades, which would be 9. So we have 9 out of 52, which again gives us our 22 out of 52, or 0.423. And sometimes we'll be given a sample space and sometimes we won't. And so sometimes method A would be better to use and sometimes method B. So we'll take a look at one last example where we're not given the sample space. So the data on people who have been arrested are published by the Federal Bureau of Investigation in Uniform Crime Reports. Records for 1 year show that 73.9% of the people arrested were male, 12% were under the age of 18, 8.4 were males under the age of 18. or 18, yeah, under age of 18. If a person arrested that year is selected at random, what is the probability that the person is either male or under 18? Now here's a case where we don't have the sample space, and the information that we have to go on, we could create different events or name different events, and then use our general addition rule. You can see that there is overlap here, so we have to use the general addition rule. So we have males, so we'll call that M, and so that's going to be event the arrested is male, and then we'll call it E for event the arrested is under 18. So we already know we can use the information given. Probability of getting a male would be 0.739. The probability of getting a person under the age of 18 would be 0.12, and the probability of getting male and under 18 is 8.4%. So the probability of getting a male or someone under the age of 18, we would add these two together and then subtract the overlap. So 0.739 plus 0.12 minus 0.084. So get out your calculator and go ahead and calculate that. And we get 0.775. Which is 77.5%, would be either male or under the age of 18. And that concludes our notes on the general addition rule. Again, that can actually be used with non-mutually exclusive events or mutually exclusive events. We just know that the probability of A and B happening for mutually exclusive events would be 0. So that's why all we need in that case is the special addition rule. And then we had the complementation rule.